Letter C. I would rewrite that.
Sir, we already did C.
We did C.
Yes, we were on D and E that you said were the most
We
important.
were on what? D and E?
D and E, yes. You said those were the
Okay.
most
Did we have the
important.
right answer for C?
Yes, it was 4.
Oh, that's good news. Okay. Oh, yeah. I remember like D, looking at that, saying it doesn't look like it's very easy to integrate the old-fashioned way. But I'm going to remind you of something. I'm going to remind you what happens when I take the derivative with respect to x of the natural log of x. What is that answer? Do you remember?
1 over x.
Andres says it's 1 over x. He's absolutely correct because we always look at the derivative with respect to x of u, and that always is du over u. So whatever is here, you take the derivative of this, which was 1, over itself, which was x. So whenever you see a variable in the denominator, in other words, it's a rational function, 1 over x plus 1 is rational. Always, always, always first ask yourself, could this be du over u? And what you'll do is you'll substitute, you'll say this, let u be equal to x plus 1. Du would have to be, well, a 1 dx. A 1 dx. Oh, you want to put the 1? I'll put the 1 there. Is this du over the u? Du on top, u on the bottom. And the answer for this problem is yes. So always check for du over u if it's a rational function. That means your antiderivative is nothing more than the natural log of u. In this case, natural log of u is natural log of, and technically they put an absolute value because the bottom, that can never be a negative number because you can't take the absolute, you can't take the log of a negative number. So I write natural log of x plus 1. If you were to put it in parentheses, nobody's going to hit you, okay? You'll probably still be okay. From 0 to 1. And this problem is one of those that nobody would know how to do unless somebody at least showed you the reverse of du over u to look for it. That would give me the natural log of 1 plus 1 minus the natural log of 1 plus 0. That gives me the natural log of 2 minus the natural log of 1. Does anybody know what the natural log of 2 is, or is that an irrational number that goes on forever?
Irrational number, sir.
It goes forever.
The
Just
one
put it-
that's defined is the ln1, right?
What's wrong with the LNO1?
It can be simplified to 0.
It's a 0. So it is defined. So it's not undefined. It is a 0. So the best answer is just say natural log of 2, which by the way is positive. So I do not have to put it in absolute value because it already is positive, minus 0. So the answer is natural log of 2. All right. This bottom one is another one that there's no way that anybody could expect you to know how to find the antiderivative. It's because you probably have forgot about the derivatives of arc sine of x. You probably forgot how to do those. I don't blame you. You probably forgot how to do the derivative of arc cosine. And then we probably forgot, which is sad because this one would help you, the arc tangent. Most of you did your homework when I graded your stuff. You put in the test or something. Most of you look like you just memorized the chart or you were looking at the chart. I was crying when I was reading your papers because I thought, how many people actually wrote the triangle? You know, that when I had y equals arc sine of x, take the derivative of both sides, y prime equals, well, no, how did I do that? I didn't do the derivative yet. I did this. I drew a triangle. And I said, I put my angle in here as y, because that answer is an angle. And then I said, I think we worked it out like this. I did this sine of y equals to x. Yeah, so there's my sine. And sine is opposite over hypotenuse, x over 1. Then we used Pythagorean theorem to get this to be the square root of 1 minus x squared. Then I went and rewrote the problem as sine of y. Then I did the derivatives. The derivative was cosine of y prime equals to 1. Solve it for y prime equals to 1 over cosine of y, which is the secant, or however you want to look at it, but it didn't matter because you're going to look in this triangle and figure out the cosine is adjacent over hypotenuse. And if I flip it to go on top, anyway, I don't want to do all these for you. It wouldn't hurt to go back and look at those. But this problem was the arc tangent. The arc tangent. When you do the derivative of arc tangent, it was this, and you had to pay attention to what was being squared. The reason I know it's arc tangent is because it doesn't have a square root in it. And there's a plus sign here. And so it's u squared plus a squared. A happens to be 1. So this answer is arc tangent of u. And u was an x. Arc tangent of x from 0 to 1. So that turns into arc tangent of a 1 minus arc tangent of a 0. And I don't blame you guys if you forgot those. You know, everybody forgets them. Unless you're like a genius, like some people in this class, not me. And so now the question is, tangent of what is equal to 1? Anybody?
Pi over 4.
Say it again. Pi over what?
Pi over 4, sir.
Pi over 4. Can you believe that somebody threw that real fast? And it's true, because here's your 45 degree triangle, 1 square root of 2. So whether I call this my angle or I call the other one, it doesn't matter. Tangent is of 1 is opposite over, or tangent of this angle is opposite over adjacent, 1 over 1. So she's absolutely right. It has to be a 45 degree angle. Minus tangent of what is 0? Tangent of what is 0? That has to be on the axes. That's a quadrantal angle. Say it again.
0?
Sure. You said 0?
Yes, sir.
Well, that ordered pair is 1 comma 0. On the unit circle, this is your sine, and this is your cosine answer. Tangent is always sine over cosine. That gives me 0 over 1. Or you could say this. What did I write? Oh, I was right. Tangent is sine over cosine. Or tangent of theta is y over x. Same thing. Y over x. So it's not 0. Let's try again. Try the other ordered pair. That ordered pair is 1 comma 0. Could that be tangent of pi over 2 be 0? Y over x. 0 over 1. Is that 0? Is 0 over 1 0?
Yes, sir.
Yes. So it is going to be a 0. It's going to be, no, tangent, it's going to be a pi over 2. Let's check this one. This is because we're looking for the angle. What angle? This is -1 comma 0.
Sir, I think pi over 2 is undefined, isn't it?
Yeah, 'cause
Oh, did I put it there?
it's not y.
Yeah, pi over 2 is undefined because cosine pi over 2 is 0.
What do I have wrong in my picture? I see it. Do you see it?
You put 1 comma, you put the wrong.
I'm
pair.
dyslexic. Okay. No wonder nobody was answering. It's not your fault. It's me. That's what when girls, all you gentlemen in the classroom, when a girl says to you, "We got to break up," and it's not you, it's me. It probably was you. So, like in this case, it wasn't you, it was me. All right. Y over X was 1 over 0. Thank you. That is undefined. So silly me. Silly me. That's not 0 then. Well, no, that's what I want. What I want, 0. That's not 0. Try this one. Is Y over X 0 here? Oh. What was wrong with this one here? Did I not? Y over, or Y is a 0. Yeah. Well, yeah, Y is a 0. 1 comma 0. Maybe Mackenzie was right. Yeah. What's 0 divided by 1?
0, sir.
That was right. Mackenzie, I'm sorry. You were right. It's a 0. That's what she said an hour ago. So I think the answer is just pi over 4 then. What did I do those 2 problems for and not hit the answer button? Let me hit my answer button. Oh, that wasn't fun. Did them all. Oh, no, I just did letter D. Is that what we had, natural log of 2?
Yes, sir.
All right, let's check E. Pi over 4? Yeah. Okay. Thanks for your help, Mackenzie. I owe you. +5 to Mackenzie. Not because you were right, but because I may have hurt your feelings.
No, I'm okay. I
Okay.
make mistakes. I'm
All
still
right, never
human.
mind.
I'll take the plus points.
Yeah.
Yeah,
I'll
give
take
it
it.
to Hector. Give it to Hector.
No, Hector, you don't need it either. You're like, you're smarter than the average bear too. You know that. So just keep that thought, how smart you are. That should be your reward. All right. Theorem 5, the net change theorem. That when you're integrating this rate, this is a rate because it's a derivative, and we always say, if I do the integral, I'm trying to get rid of the derivative. So that's why this part comes out to f of x. And then if I'm going from a to b, that's why I'm saying f of b minus f of a, and that's what he has here. He's calling it a net change because usually a rate stands for like miles per hour, gallons per minute, feet per second. Those are rates. Everything you integrate is a rate. Think of it as a rate. Here are some very famous, well, this one was really more complicated. I got the other one I'm going to do is nicer. Back in a previous chapter or previous lesson, we said that C of X was a function that was the cost of producing X units and of a certain commodity. Okay, so C prime would be the rate that you are producing these objects. So if you are making widgets and you were selling them, and your widgets cost you 2 cents to make a widget, but when you sold it to the person who's going to sell it to the store, they gave you 3 cents. So you're making a penny off of every widget. So when you think about this as a rate of widgets, if you want to make more money, you want to get to make more widgets. You want a faster rate. Because if you're only making 100 widgets a day, you're only going to make 100 cents a day. If you were making 1,000,000 widgets a day, and you could get rid of them to that middleman who's selling them to Circle K, then you can make 1,000,000 pennies a day. You see what I'm saying? So this is a rate, and a rate is a function. A rate is a function that you would hope if you're making widgets, you want higher, you want by the day, end of the day, you want to be making a whole bunch. You want this to be very fast, and you want it to be higher and higher and higher. If you're making widgets and all of a sudden it does this, oh, then you're not making any widgets per hour. You're going to lose money, okay? So this is a rate. This is my C prime at time. You want to make more widgets because you want the rate of change of how you're making them to be bigger. So what he wants me to do is actually set this up. So I didn't even realize it this morning what he wanted me to do. He actually wanted to say that if I integrate from some time or some X, what was he doing? He's doing X. Some X value to another X value of C prime of T, out comes out the net change that when you, this is like when I started at the beginning of the day, this is what I started at the end of the day. You want the net change to be big because you want to make more. So that would be C of X sub 2, because when you integrate C prime, you get C. That's your antiderivative, minus CX of 1. You want that to be a big number. You want it to be like, by the end of the day, I was doing 1,000 widgets, and at the beginning, I started out with only making 10 widgets. And so I made a whole bunch of widgets. That's a net change. I prefer, and there's what he's talking about, same kind of idea. I prefer to think about driving a car. And so you're driving a car, I'll start at 0 just because, even though I might graph the whole thing. You get in your car and you're at 0. Maybe I should go down here. You're at 0 and I'm going to work. And so I start out and I'm not going very fast. And then I go steady, 50 miles an hour. And then I see a cop, so I slow down. And then I speed up to get to work on time up. And then I realize, oh man, I forgot my phone at home. So then I slow down, turn around, and go the other way. This is negative velocity. Negative velocity. This was positive velocity. So my net change could possibly be, let me finish it up. I drive straight home, and then I slowing down at my house, and there I stop the car. I stopped the car here too when I turned around. I stopped the car here because I'm sitting in my driveway. So look what my net change became. I drove 13 miles before I realized I forgot my phone. This really happened. This really happened yesterday. So turned around, because yesterday was not the first time I did it. I did it also on Tuesday. Yeah, it was Tuesday. And I didn't know I didn't have my phone until I got to work, and I realized my daughter didn't call me. She always calls me on the way to work. She works in Raymondville. So I got kind of worried, and I'm looking for my phone to see what happened. And I realized I didn't have my phone, but I didn't go back home. So this would be a negative 13 miles of air. Think about what we're doing. When you integrate underneath this curve, and that curve was the rate of change of velocity, the area under the curve becomes distance traveled. Well, that was 13, and this is negative 13. Then my displacement, which is a word coming up in a minute, my displacement is 0. Displacement means if you start moving, let's say let's do an X, just a straight line. And if I travel this way for 13 miles and then I stop and then I travel this way for 13 miles, where's my car?
At your starting point.
At my starting point. So my displacement is 0. But how come I burn gas?
Well, because you went a total of 26 miles now.
How much did I go?
26 because you went 13 and then 13.
Yeah, I drove 26 miles for nothing. So when we talk about,
Well, it was for your phone, sir. It's pretty important.
because I was like, well, I don't have my Apple Watch right now either because it's in the shop. So I was like, oh my gosh, I'm just dying. So technically, when we do the 13, I'm really adding an absolute value of 13 because this function went under the axis. And what happens when you take the absolute value of a function? Let's pretend I knew what this function was. What happens, the absolute value of anything is always positive. So the absolute value graph would look just like this, the same. But then this graph flips up. So that way I'm looking at 13 plus 13. That's my total distance. Total distance may not be the same as displacement if some of your displacement became a negative answer. You see what I'm saying? This is not like, I'm not wasting time. This is actually coming up. It's coming up in a minute here. If an object with the position function s of t moves along a coordinate line, and its velocity is s prime of t. So you can see right here, velocity is s prime of t from time 1 to time 2. So it makes all the sense in the world that if I'm integrating a derivative, it's going to give me s of t from, in this case, time 1 to time 2. So that becomes s, the distance you traveled, your position at time 2, minus your position at time 1. So mine was, from my time 1 and time 2 was, how was it? It was, well, 0 was my time 1. So however time it took, my second position was 13 miles. And then I had another 13 mile, but it was the other direction. Now, in this particular equation, I think if you think about solving this problem in a different way, if you just say, look at this problem, I'll go right up, skip this part because he didn't do this. If I solve this for either of these, like I solved this for s of t sub 2, s of t sub 2, which was my antiderivative at time 2, would be equal to my integral from time 1 to time 2 of s prime of t, or velocity, plus s at time 1. That's what he's showing you here. Now, when you see an equation like this, I want you to realize that this is still the same answer that I had up at the top. But this, let's put it in terms of velocity and distance. I'm integrating this velocity. Therefore, I'm creating some distance, right? This was my original position. So when we go to San Antonio or Austin, my wife and I, and sometimes we have a grandkid, and we're going to travel, we always go out of our way to get snacks, and we don't go to Circle K because it's too expensive. Well, we go to Circle K to get our gas. So we're actually driving to Circle K or Stripes to get gas, or we just go straight to H-E-B, which is farther, because H-E-B has cheaper snacks and cheaper water. So we have to drive maybe 6 miles, 7 miles before we even go to the expressway to drive to San Antonio, okay? So this is like saying that my new position isn't just how far I'm driving to San Antonio. It's because I already drove 7 miles. before my time 1 or my time 0, however you want to put it. Call it time 1. And when I get to San Antonio, that's time 2. So I wasn't even watching the clock because this is where I start my time to go to San Antonio. But in reality, my distance also has to include driving to the HEB before I went. So this is sort of like an initial condition. It comes up later. You'll see how it pops up. I don't think it pops up in the example he's doing here. No, this is the same stuff I just talked about. But the good news is he is using the word displacement and he is using the word total distance traveled. Because when we're going to do a problem, that one does come up right here. Okay. I got kind of lost on this morning because I couldn't remember the problem. He was talking about consider analysis of a heavy rock that was blown up in the air back in lesson 1. I just don't remember the problem and nobody could find it. Obviously, the rock goes up and then the rock has to come down, right? And so he thought we would remember this problem and I don't. Anyway, there's a blast of dynamite. The velocity of the rock at any time. This is the velocity of the rock. It's not the position of the rock, like I would like to think it would have been. Maybe that's why I was having trouble for a little bit. I didn't get under I didn't wrap my brain around that it was a velocity function. So if it's a velocity function, you need to realize that when I start, my velocity is 0. Velocity is also 0 before it turns around. So my velocity at time 0 is 0. And my velocity up here at some time, I don't know what it is also going to be 0. Okay, and he gives me the equation, the velocity. A, find the displacement of the rock. Well, that's actually the easy problem to do. Because when I do A, I'm going to take my integral. He says I'm going from 0 to 8, 0 to 8. And underneath this integral, I have to put the velocity equation. Because that's a rate. Velocity is S prime. Or if you use position as P, or you could say P prime if you use position. So underneath the curve will be my velocity, V of t, dt. So I'm integrating this. It's not that bad. I'll write it out. 0 to 8 of 160 minus 32 t dt. This is not too hard. This will give me 160t minus 32t squared over 2 from 0 to 8. I will plug in my 8. 160 times the 8 minus, that becomes a 16. 16 times 8 squared. And if anybody could do that math for me, 160 times 8. Somebody should have a calculator. While they do that, I'm going to do
1,280.
1,200 what?
80.
80. Okay. And then was that with a calculator? Could you do 16 times 64?
Well, I just did 16 times a and then added a 0.
Oh, that's very smart. Then what's 16 times 64? Anybody?
Oh, I need a calculator.
How much? 1,024. And so that gives me left 176 plus 80, 80 plus, I lost track already. I need more toes. Oh, okay. 256. 256. And this was a been in feet. Feet. Yes, sir. Oh, 256 feet. That was displacement. That meant at some point of time, the rock was blown up and it's coming back down. The question is, 256 feet could be the whole trip, or 256 could be here, or 256 could be here. The height could be there. It could be looking down here. You want that printout? Is that what you wanted? I just remembered. Okay, you sent it to email?
Sure.
Okay, let me,
Are they seeing your screen?
no.
No, this screen here.
Sir,
Yes, they see that. Where's my
when you,
printer?
sir, when you're talking about displacement, are you talking about vertical or horizontal?
Well, in this case, it's the same thing. Let me, I gotta print something for Dr.
Oh,
Garcia.
okay.
Hold on here. I can't do 10 things at once.
Oh, you can.
Where's my printer at? Oh, email, right? You emailed.
So they
There you
can't-
are.
They can't see it?
They can't see this, no.
Okay.
No, they're seeing this.
That right there.
Oh. How come you don't have a printer? Where's printer? I don't see print.
Quick print.
Where's quick print? Quick print, okay.
Mhm. And then print that one.
Oh, gosh. Oh, it's opening. There it goes. Quick print. Okay. You happy? The other one didn't go yet?
Nope.
Oh. Yeah, there it is.
Wow, open it up.
I'm busy, man. I gotta work.
Okay, go ahead. Go
I
ahead.
gotta teach.
Go ahead.
Okay, Hector, you were asking, okay, this is the location that it could be. It's possible that I went all the way up. What was my answer? 256. It's possible I went all the way up to 256, and that's the very top in 8 seconds. Or it's possible that we're not at the top yet. Okay. Or it's possible that it went to the top and it's still going. This would mean from here to here, if you stretched it out, would be 256 feet.
Oh, okay. Okay.
Okay. Now, the hard part is this next B. Question B says, what was the total distance traveled? Well, because this is the resultant. If you think about it, we could be doing positive distance and then doing negative distance, and we could be canceling out some of it. So the best thing to do is to, well, first of all, I need to talk about integrating this thing. This is B. 0 to something plus something, the same number, to 8. That middle would be, well, what if I go to the top and I end up changing directions? So what we want to do is talk about the absolute value that I was mentioning before. The absolute value will make all those negative distances become positive. Okay, so I'm going to figure out when would it become negative? When I reach the top. So if my velocity equation was equal to, was it 160 plus 32t? As I said before, velocity is 0 at the beginning and it's 0 when it turns around. Let's see if it turns around before or after 8 seconds. Let's see. 160 equals to 32t, divide both sides by 32. The other time it takes to get to 0 velocity is, what is that? 160 divided by 32. Is it 5? 150? No, yeah. 32 times by 150, 160. It's 5. 5 seconds. 5 seconds is between the 0 and the 8. So I'm going to write out 0 to 5. Am I right? Is it 5? Did anybody else do the math? And 5 to 8. Of the 0 to 5 is definitely positive, because I mean, it doesn't really matter if I say it's positive or not. I can say absolute value of the velocity function, absolute value of v of t dt. plus the absolute value of v of t dt, and it doesn't matter if one's positive or negative, because an absolute value of a positive function still will be positive. The absolute value of a negative function becomes positive. So let's write it out. That becomes 0 to 5 of, we're still doing the same work, 160. Was it minus 32 or plus 32? Minus. Minus 32 t dt. Minus, and the reason I'm going to go minus, let's see, what is the reason I'm going to go minus?
Wait, sir, you put a 16. Is it not 160?
160. Yeah.
Okay.
Thank you. Integrate from 5 to 8 because it was. Why am I doing a minus? Oh, because we're going down. So it was a negative. We know it's going to be a negative distance going down because it went up. In 5 seconds, it goes down all the way to 8. So it's going to be in here somewhere. 160 minus 32t dt. We can go quicker now because we've done this already. 160t, but I need you guys to do the calculations. Minus 16t squared from 0 to 5 minus 160t minus 16t squared from 5 to 8. By the way, you could put all this in a calculator. I already showed you the other day how you could integrate with a calculator. It's kind of nicer. 160 times 5, somebody.
800.
Okay. 800 minus 16 times 25. Why is nobody helping Hector?
400.
400?
Yes.
Okay, so that's plugging in the 5. Now I got to plug in the 0. What happens when I plug in 0 here and 0 here?
It becomes a magical number.
0.
Minus 0. Okay, I don't have to think that hard. Minus. Plug in the 8 now. 160 times the 8 minus 160. I did it again right here, Hector. 160 times the 64.
Well,
No.
no, it would be 16 because it's 32.
Oh yeah,
divided
you're
by
right. That one is 16. Yes. I saw. That's probably why I did it wrong the other way. 16 times 64. And this time I got to plug in the 5 because it's not going to magically go away. Minus, this thing is in a bracket. That minus is in front of that whole thing. Minus 160 times 5. It's ugly, guys. Minus 16 times the 25. Okay, that, well, I don't care if I need a parenthesis, but definitely I need one parenthesis for that whole thing, and then the big bracket for that to close this whole thing. All right, what do I got? Well, you calculate while I'm going to type this in, or not type it in. 800 minus 4 is 400 minus, what goes here?
Well, we already did that one, so it would be 256.
This is 256. What's this one? 16.
400.
400? This is 400?
Yes. Well, no, it would be 256 minus 400, the total.
Oh,
Because
the
we
whole
already
thing
did.
is.
We already did the one with the 8 and the 5.
Yeah. Okay. So you're happy with this?
Yes, because then it would be
That's
the total
400
would be
then minus what?
negative 144.
144? That becomes 400 plus 144. So the total distance traveled is more than 256. 256 was the displacement from where the position was here to here. Where is the rock at in this interval here? Because it goes backwards and forwards. So the rock actually traveled 544 feet. That's how far the rock actually traveled. But he's not 544 feet away from the ground. That's how much he traveled when he started going up and then he stopped. Not stopped, but I'm saying in 8 seconds. So I was correct that when it went up, he was this high, and then when he was coming down, he was that high again. But this is the distance. And you can do some more math and calculate some other answers, like how long did it take to get to 256 the first time, or here? This was a total of 256 travel. It isn't hard to figure out how high he got, because that's the easiest thing. We already know it took 5 seconds. You could calculate if you wanted to do more math on it. What did he do over here? 256 in 8 seconds. Yes. Supposedly we were supposed to know that from the other problem. Then they did a table in that one problem. And what did they find out? Okay, here's 0 to 5, here is 5 to 8. He did it quicker. Well, no, that's ugly too. Same answer. He says, again, this calculation agrees with our conclusion before, but we don't remember that. What did he say? He says the maximum height was 400. Well, we had that number in our work somewhere. I saw 400 right here. That was our maximum height. Okay, that was fun. This was, I think I forgot to switch the pages around. That was this problem. We have two parabolas, and here's your x-axis. And one of the equations is x squared minus 4, x squared minus 4, or plus 4, x squared minus 4. That's this one, right? No, it's not. Where's my x-axis? Right there. There's my x squared minus 4. Oh, the axis is up here. I'm really curious. Oh, there's 2 different pictures. Sorry. That's 2 different pictures. Here's x squared minus 4. It moved down 4. It's upside, I mean, it's correct. This one is upside down, and he went, basically you're going up 4. Okay, he wants you to find the definite integral of both of those from -2 to 2. He says something that you ought to take note of. He said both pictures are reflected across the x-axis. Here's why that's going to help me. If I want to integrate the first one, integrate from -2 to 2 of x squared minus 4 dx would be a lot of work, because you're going to have to do, you're going to need the x cubed over 3 minus 4x, and you got to plug in the -2 and the 2. But what if he gave this for a reason. He's giving you a trick. If you got reflection over the y-axis, that means there's symmetry. Ignore this negative part, because the area of this orange would be 2 of these. So I can do it as 2 times 0 to 2. I love it when the zero's in the bottom, because there's a good chance that that whole thing will be 0. Not guaranteed, but there is a good chance. And if I look at this, minus 4x from 0 to 2, look what happens when I plug in a 0 here and a 0 here. Will it go to 0? It saves you some work. So that gives me 8/3 minus 8, whatever that answer is. That would be 8/3 minus 24/3. That's a -16/3. Oh, I forgot to do something and nobody told me. There's a 2 out front, 2 out front, a 2 out front, a 2 out front. That should be a -32 out of 3. Okay. The other one, this bottom one here, that's integrating. I'm going to go from 0 to 2 again. And it was a 4 minus x squared. 4 minus x squared. You want to predict the answer? Is it the same, you think? Let's see. You might be smarter than the average bear. Let's see. Nobody's disagreeing with you, Andres.
I believe in him.
Okay, 4x, we'll see. We'll see if that's your famous last words. From 0 to 2, and again, when I plug in the 0, it's going to go away. I just care about the 2. 8 minus 8/3, that become, oh, times 2, forgot that. Again, Cartwright, you're fired.
Sir, I mean, you can just put it at the end.
Well, I don't like to people just magically double something. I want to see it in the problem all the way through. I know
Oh,
what you're
okay.
saying. That's 2 times 24 thirds that's the positive 16 thirds. That's a 32 thirds. Is Andres correct? Are they the same? Oh, one's
No.
negative. He saw the errors of his wicked ways. You knew that was gonna happen. Why didn't you tell us if you knew it was gonna happen?
He wanted to trick us.
Oh, you mean the total area is the same, but the integral is not the same. The integral is sort of like displacement. You know, Andres, good point, because you can't go to the store. If I erase all this and I'm going to go to the store and say, okay, paint store, I need some positive paint. I need to buy a positive 32 third gallons, okay? And then that would be a negative 32. I need negative paint, please. I need negative 32 gallons. Then this will be my positive paint for a positive 32 thirds. I need some gallons of paint. I need some positive paint and some negative paint. It doesn't make sense. It's the same amount of paint. It's just that this is below the x-axis, negative area. Just like when I turned around and went home, that was negative distance. All right, let's do another hard one here. Oh, this one is actually not hard at all. We're doing f of x is sine of x from x is 0 to 2 pi. He wants just the integral, a. Integrate 0 to 2 pi of sine of x dx. The integral is the antiderivative of sine. The derivative of what is sine? I think it's a negative cosine. We had that before. Because the derivative of sine is cosine. The derivative of cosine
is negative.
Negative sine. So I have to put a negative out front here to make that doable. So to cancel that one I put here, I put one out here. That's why the answer is a negative cosine. From 0 to 2 pi. That gives me a negative cosine of 2 pi minus, this is the minus because we always put minus when I do the two pieces, minus the negative cosine of 0. Really quick, guys, what's the cosine of 2 pi? I'm just going to draw the picture all the way around right here. What's the cosine of, what's the x number of that dot? No, it's not. I'm right here.
1.
1. Oh, Andres, you mean this thing becomes a negative of a 1.
Well, it's
Minus,
because
minus.
I was gonna ask is that the little horizontal line at the left of the S sign thing, is that we're multiplying a negative 1?
Oh, I was just showing you, yes, that's what happened in reality. Because in order to take the antiderivative of sine, it would have to be a negative sign to get the answer of a negative cosine. So in reality, if you put two negatives, it cancels out, but that first negative doesn't go away. It stays as part of the answer. This one is what I needed to make happen in order to be this. This had to be a negative sign in order to get the answer of a cosine. So I had to add it. So if I add it here, I had to add it here to kind of balance it.
Okay.
Those little tricks, we did it like already like 10 times, but we just memorized it. All right, minus, minus, plus, what's the cosine of 0? Right here, cosine of 0.
That would be 0. No, I don't know. I'm confused.
Me too. Cosine's not 0 there. That ordered pair is 1 comma 0. It was 1 comma 0 both times. Let me go back up and see if there's anything.
So, oh, we're doing from 2 pi to 0.
Yeah.
Oh, okay.
Did I do something wrong?
No, I miswrote it. I put a 6 on accident.
Was it 2 pi or did I write it wrong? No, it says 2
No,
pi.
no, it was just me. It was just me. I was writing fast to catch up, and I put a
All right,
6.
so I think
Have
it's a
it.
-1 plus another 1.
Yes, it would be 1.
I think the answer should be 0. And we'll check it. Mackenzie's not yelling at me, so, and neither is Evelyn. She always catches me. B. B just wants the area
Wait,
between the
sir,
graph of f and the x-axis.
sorry to interrupt again, but
Yes.
are we, so would it be the negative cos of 0?
Well, the derivative of what is, what did I have there? Sine. The derivative of what is sine?
Negative cosine.
Oh, that's what I put. Negative.
Oh,
cosine.
okay.
Yeah.
Okay, well then wouldn't it be -1 plus -1? Because if
There was-
cosine of 0, if cosine of 0 is 1, but it has a negative in front of it, wouldn't that
Well,
make
maybe
it?
you're right. Let's check again. Oh, but there's a negative though stuck in both pieces though, right? This minus is because of when you do the top, you go minus, you put in the bottom.
Oh, you make it positive. Oh, my bad.
Yeah.
That was my fault.
And let me show you something. This might even make it more clear. We've looked at the sine graph a million zillion times. From 0 to 2 pi looks like that. This is positive area, this is negative area. Don't you think that if I did the positive paint and then I bought the negative paint, I'm not buying paint, but the integral says positive area minus area. These values are the same because it's symmetrical. So it does make sense that the answer is 0. But B is saying, I don't want to know the integral. I want to know how much paint do I have to buy. So now when I do integral from 0 to 2 pi of sine of x dx, I'm going to take the absolute value of it. And realize that when I take the absolute value of this function, and I graph, go ahead on your calculator, graph y is abs of sine of x. And you're going to see that the picture looks like this. I'll do it in black. Looks the same, looks the same, looks the same. Then it goes, woo, like a roller coaster. It's going to keep doing this because the absolute value of negative is always a positive. So everything stays up. Every time there's supposed to be a negative, it flips over. So now what happens is I have this piece plus this piece will give you 2 positive areas. So all I really have to do is, if you want to make it simple, why don't we just find out from 0 to pi? Just to keep it 1 positive and realize my answer is 2 of them. So Hector, the integral of sine is negative cosine. And I got 2 of these things from 0 to pi. Now I got 2 times, or I'll call it a -2 if you want, -2 cosine of pi minus a -2 cosine of 0. And that this minus was the separation of the upper and lower limits. Pi is here, -1, 0. What's this cosine of pi? Cosine of pi, x comma y, cosine zx.
Wait, so is it pi or 2 pi?
I changed it to pi to only do one of the loops.
Oh,
Then I'm
okay.
going to double it to get the other one. I'm just using some common sense to what the picture looks like now. Forget this bottom piece. I have 2 top pieces. They're the same. So if I do 1 and double it, it's the same answer. Could we do it with 0 to 2 pi? We could, but then I don't double it. I just go 0 to 2 pi of the absolute value of sine of x. So that means in this case, you'd have to keep the absolute value with you the whole time. Make sure none of those numbers are negative. So back again, cosine of pi.
-1?
It's a -1 because it's the x value. Minus minus still is plus. Cosine of 0, that's here. 1 comma 0.
1.
That's going to be a +2. So that gives me a 2 plus 2. Why? Because if you'd have just done the 1, if you had just done the 1, it's without multiplying by 2, that answer is a 2. The area from 0 to pi is 2. The area from pi is a -2, and that was a 2. That's why they canceled out. But the total paint you're buying will be 4 for 4 square units. There's his negative, there's his positive, there's his 4. There's a picture, same thing. And did not get to finish this last problem, which was, I had an error in there. And I think it was, is it Esma? I think it was Esma had it right. I was off by a fraction. So I'm going to do this again. And I'm going to send this one just to you guys because they already saw it. Or you can watch the whole video. That was the last problem. After this is the homework problems. And I got to do, what I'm going to do for you guys, I mean, I'll do it for everybody. I'll do this problem. Then I'll do some of the homework problems. Because there's a couple bears in there. There's a lot of homework problems. So I probably could do a handful of those too, okay? FYI, this homework won't be due until obviously Friday, right? My math lab will be due Friday. Textbook homework due Friday, next Friday. Quiz due Sunday night, midnight. And everybody's leaving and no one even saying bye.
No, I'm still here.
Bye, sir.
There's somebody who said, hold on, don't go yet. I guess who it is.
Sarah, I have a quick question. So for the quiz, it's due Sunday midnight, and it's on It's Learning, or is this for dual?
Well, yeah, good point. I haven't put it up anywhere yet. Are you waving at me? Or are you saying bye, Sienna?
I'm saying bye.
Bye, Sienna.
Bye, sir.
Okay. I don't know where I'm gonna put it. I might make it Math Lab.